afternoon and welcome to the Building Designers Association of Australia. Hi, Kirsty. I'm pleased to see that you're here today. Welcome, everyone. I'm going to actually hand it straight over to Kirsty and she can get the meeting started.
Well, thank you everyone for joining us today, and thank you everyone who has joined us throughout the year. I'm joining you today from the beautiful Blue Mountains, the home of the Darug and Gundungurra people, and I'm filling in for Jennifer Binns, who's your usual host, who's having a well-earned break this month. So this is our last meeting for the year, and we'll be having a little bit of a break, and we'll be resuming our usual national online meetings back in March 2024, and that will be on the first Tuesday of every month at 1 o'clock. So looking forward to seeing you for next year. So in news this month, if you're looking for the next big move in your career or have a job vacancy that you need to fill, then the BDAA Connected Community Portal is the place for you. This is a jobs board that is specifically designed to connect talent with opportunity within our unique building designers community. So log in and get online today and check that out. Also, for all of our student members, a reminder that we have the Green Facelift Student Challenge. This is a collaborative initiative from the BDAA, ITI Australia and WeatherTech. And the deadline is very soon, which is the 9th of December. So for this competition, they're looking for someone to redesign the facade of the ITI building. And it's not just an empty prize. You can win both $5,000 and they will actually build your project. So for students out there who are looking to get some both recognition and some work built, this is a great opportunity. So for anyone who's a student, so you can either be a student this year or a student member, which includes those who are in their first year out. So for all those students, this is going to be a really great opportunity. Don't have very much time left, but what you need to do is download the DWG file that has all the information, bring out all your best ideas, use all the great products from ITI and WeatherTech, and all you need to do is just check out the website to find out all the information, and Sarah Jane is going to put the link in the file. So for today's meeting, we're going to be talking about building in high bushfire areas, which is going particularly relevant as we're coming into summer now. And hopefully this won't be a particularly high bushfire summer, but we've always got to be conscious of that for everyone who's building in high bushfire areas. So if you're looking for some great ideas about how to build cost effectively and thermally efficiently in high bushfire areas, then we'll be talking about that today. So our first speaker today is Corey Webb from Corey Webb's Design. He's based in Western Sydney and has extensive experience in high bushfire areas as well as passive house design. So Corey, I'll throw over to you. Do we have Corey?
Hey, Kirsty.
Fantastic.
Apologies for that. We're right to go?
We're good to go. Looking forward to presentation, Corey.
No worries. All right. Bear with me for one moment. Screen, let's try that screen too. Can you see that okay?
Not yet, Corey.
Okay.
That's fantastic. We can now see your presentation. You might just want to put it into presentation view.
Is that clear now?
That's beautiful.
Right, no worries, sorry for that. So everyone, I'm just presenting a passive solar designed flame zone house. This is here in the Blue Mountains, worked with local bushfire consultant Craig Burley from Control Line Consulting, and he helped a lot with this project in guiding us and giving us advice. So what I'm going to do today is just run through what influenced the design, what were some of the bushfire design strategies that we implemented, and if there's any other sort of learnings that we can share from it. So some of the major things that influence the design is the topography. We've got the road in the middle of the screen there. It drops off to 8 meters down the site, and then on the edge of the site there where the bush starts is pretty much a cliff and national park. And if you know the Blue Mountains, it's kind of where Jellybean Pool is. There's also some rock formations on the site which we wanted to keep as well. These are some of the views of the finished product overlooking the pool, looking out to some of the mountain ranges. So this is a really important part of the consideration, is trying to get as much access to these views for the bedrooms and living areas of the house. With the topography of the house, of the site, the existing house is basically in the same excavation sort of footprint, so to speak, in that it was already an existing brick veneer house there that was removed, but we didn't expand beyond that existing footprint because we didn't want to increase the excavation to keep the costs down, but also because there was so many rock outcrops nearby that we didn't want to disturb those. And so the house appears from the street as a single story, but it's actually a 2-story dwelling. And in terms of bushfire, because of that topography and the proximity to the forest and the extreme slope, it had a flame zone rating. But on the east, so on the left of the screen there, we had about 40 rating, so on the front facade. There was also some planning overlays that we had to go and contend with. A 5.5 meter height limit, view sharing for properties across the road. And also to fit into the context, council wanted us, and we also wanted to make sure the house fit in the street well, so that there was ability for to have the sort of good rhythm and of form through the street as well. So this is an aerial shot of the back of the property completed. And as you can see here, we've got on the top floor, the living areas on the left, and then master bedroom and ensuite on the right, and then downstairs, all the bedrooms running along this face. So this is all facing west. So a lot of potential for overheating in summer because it's west facing, but it's also the view facing. So as you can see there, we've used a couple of mechanisms to control that, which we'll go through in more close-up shots throughout. But basically, I've got an oversized colonnade on the lower there with little decks with recessed doors, and then upstairs with an oversized eave and pergola to give that protection, solar protection in those areas. In layout, we've got the entry level, or that upper ground level we were just talking about, that you enter through on that deck. There's a little bridge that runs over to this deck, through the front door and into the kitchen, living, dining space, and you can see through out to the views through. And then also the client was really keen on having an outdoor bath, so we incorporated a sliding folding door between the ensuite and the outdoor bath, so you could fully open that ensuite up and enjoy the views out there. And as you can see, like, it really wanted to bring the natural biophilics materials of timber and stone throughout the design as well. Downstairs, again, we had the bedrooms running along this face, so they can all take advantage of the views. And his image from the guest bedroom looking out over the pool area and the bush in the background. So in terms of style, the client really wanted something that would fit in with the context, the natural context of the site. So the topography was sloping away from us down the site. So we designed the house roof to have that same sort of form, so that it would be synchronized with the topography and fold like a page of a book, and then let in a lot of that early morning light into that main living space. And then also in terms of materiality, we wanted the context of like the forest, the stone, and the like to be reflected in like the corten and stone base, corten cladding. And the finished product also had that, so these corten and sandstone sort of finishes, so it would age gracefully, but also that we were able to design the facade to fully open up on both the front and back of the house, so that you could have the benefits of ventilation through there in good weather, and also generously shared that view with the passerby on this quiet road. So it was quite a open house, but then very good access to views and the like. Internally, we had these west-facing windows, which got open in this photo, and then the highlight clerestory, which let a lot of light in, but also was able to give a view, access to the view from many parts of the house as well. And as we said, when we were looking at the topography, the form was designed to be partly submerged, and then this sort of dominant sort of upper level, which was really just at ground level, would look like the main thing, the main show, and the roof was designed to really float above, and able to capture a lot of light and warmth through the day with the amount of glass in there, connecting it with the bush as well. So that's sort of a bit of the thinking behind the design and material choices. But now we'll dive into the bushfire design strategies. So in flame zone, the highest bell rating we're probably all familiar with. We know that it's possible to build with a timber frame and be compliant, but for this house we went for something that was more durable on the ground level and had concrete block construction for the lower ground level, and clad that with sandstone. And those openings along the bottom there, we'll dive into them a bit more, but they're all bushfire shutters on those big openings to protect behind. Also the cladding, we know that fibre cement is possible and other claddings possible to be used, but we went with something that would weather really well with the corten steel aluminium cladding. And just for those technically minor, we went with the Hardy wall, James Hardy wall system for the FZ wall system. You can't see it in this image, but on that bottom right shot where there's a few outdoor chairs, underneath that deck is a underground RFS bushfire tank, and then to the right there we've got the swimming pool as well. The swimming pool positioning was important as a bushfire design strategy consideration, because putting it between the threat and the house meant that RFS can come down, use that water and defend the house, and they've got a bit of a defendable space to retreat back into, instead of having the house right down the bottom of the block, bang on the bush, where it would have been challenging. So we were able to sort of combine this desire to have good solar control with the bushfire strategies. Up on the upper level, we've got sort of natural light flooding into this main living area, and we integrated into the behind that beam above the door the bushfire shutters, so that basically it was hidden internally. And then on the shot on the right is a shot of the corten lining of these block walls, where we had the the bushfire shutters recessed up into the soffit, so that they're basically invisible, even though very important function. So in a more technical sort of wall section through that area, you can see on the terrace level up above, we boxed out this Corten pergola and had the bushfire shutters sitting inside that. And then down on the lower level, you can see the section through where the bushfire shutters are sitting in the soffit underneath the first floor slab. So during construction, what did that look like? We had the shutters all framed up and the pergola all framed up, and then it was on the left image, and then on the right all clad with the aluminium Corten style cladding. And then construction shots for the soffit, where you can see the bushfire shutters has been fixed down the side of the slab, and then that was concealed with fibre cement. So one strategy to sort of minimize our costs for the client on this build was, instead of having on the lower ground level there's 8 different windows, some butt glass windows, which are normally pretty difficult to do in flame zone, and terrace, little decks or terraces along there. Instead of having individual shutters for each of those, we went for more bang for the buck and put the shutters out at the front face of that colonnade, and that way we could reduce the number of bushfire shutters by 5. It's roughly, for the big ones, they're sort of 5 to 10 grand, so significant saving, cost saving there. The roof construction, we deliberately kept it very simple, because complicated roof forms are very challenging in flame zone. And so we've got just 2 single skill-in roofs over the upper sections and some lower ones over the ensuite and kitchen. The construction, we used the Promatec Bal FZ tested system for the roof construction, and this has recently been bought out by I think it's Cineat, with the weather defense product. Promat's sold it on to them, and this is really good system because the Promat, or the weather defense at Cineat now, is vapor permeable and tested for Blair flame zone, so it reduced the amount of risk of condensation, which there's been a bit of discussion about in the industry. Just in terms of that comment, so for the condensation issues that can occur, and specifically to flame zone Appendix H roofs, is that quite a bit of moisture can be trapped in the roof, as we can see in that top roof. And so I didn't use it on this system, but on all projects going forward, we're using that best practice system down the bottom with a ventilated sarking zone to allow the air to flow out through there. And that's possible with the detail that Mark Davis has shared with the BDAA. Also, part of the strategy as well was putting the RFS tank below the ground and the in-ground swimming pool. Putting these at the back helped with the storage of water for reuse, but also and allowing for protection against fires. With the subterranean walls, we created a false wall and detailed very specific drainage around there, so that if there was any compromises of the waterproofing, that the drain would drain it all away. The landscape design, we designed the property to have non-combustible landscaping elements within 6 meters of the house. So we've got concrete steps at the back, and then around the pool, so for less necessary paths, we were able to change it over to the timber. There was a dry creek bed which was able to, in the backyard there, able to sort of filter the stormwater from the roof, and then through a system there to filter it all out. And also we used a lot of very low native planting, so that there isn't fire sources right next to the building. So that was an important part of it, and at a recent bushfire conference, that was sort of drummed into everyone, to pass on to everyone, is instead of putting plants against your buildings in bushfire areas, encourage everybody to have a non-combustible path basically around your house. And so we'll just take you through some of the other rooms we haven't shown yet. This is just walking into the main front door, and then access into the living area. Shots and detail shots of the kitchen, again using the same timber, and the connection between indoor and outdoor in the bottom right shot there as well, in the guest bedroom and that ensuite. Some vertical batten screens for a bit of privacy in the home office, and nice lighting in the stair, and then the pool. So some of the things that the main things that we did was using durable materials, so concrete clad at the base with sandstone cladding, the Corten style aluminium cladding with the James Hardywell system, and the ProMat Cineat tested system that's called Weather Defense for the roof. And the strategy of giving the RFS the access to the water in the best possible location for them. And then incorporated sustainable design elements as well, of the building form with the oversized eaves and deep overhangs to west elevation. And we did a lot of sun path modeling to increase the amount of sun we could get in there in winter and control it in summer. So that's the end of my presentation. Thanks. So I'll hand back to you, Kirsty.
Thank you very much, Corey. That was fantastic, and what a beautiful house. We've had some wonderful comments. What we might do is we might go on to our second presentation, and then we'll come back and bring you back on and ask all the questions then. And for our second presenter, strangely enough, it's going to be me. Corey and I did a double header at the Bushfire Building Conference, talking about some BALFZ rated houses and strategies that could be used. And we're now giving you all of the this wonderful sort of sharing all this wonderful sort of information with you. I'm just going to bear with you a moment, share my screen. Bear with you a moment. Sorry about this. I've got too many things open. Okay, and fantastic. It looks like hopefully we've got my presentation on. So
yes,
today, thank you very much. Today I'll be talking to you, of course, like Corey, about another BALFZ home, and probably the most interesting and unusual aspect of this house is that for the walls, we have used hempcrete. So I'll be talking to you today about the use of hempcrete in high bushfire areas and why it works and why you'd want to do that. So first of all, in terms of the brief, this is actually quite a small house. It's up at Blackheath in the Blue Mountains. It's in a very high bushfire area. And the brief was for a small house, solar passive, high insulation, using natural materials as much as possible. Unfortunately, north is sort of to the front corner, and that's how we've sort of ended up with an L-shaped design with a deck which can capture the sun in winter. So in terms of that, having a look at it, what is hempcrete? So not a lot of people have come across this, and it's really a fantastic material to use in high bushfire areas, and for many other reasons, but one of them is it's non-combustible. But basically what it is, it's made from the hemp herds which are the inside of the hemp stalk, and it's mixed together with a lime-based binder. It's usually poured into a formwork on site, although you can now get hemp blocks, and they also could do spray installation. It is non-load bearing, so inside the middle of the wall there is actually a timber frame. We'll have a look at that. But in terms of that, where did hempcretes come from? Basically, it started in France in the late 1980s, where they were wanting to retrofit these wonderful half-timbered houses from the 15th and 16th century. Now, when they used non-vapor permeable materials like concrete, they actually came up with problems of the buildings rotting. But they also needed to try and bring these buildings up to European thermal standards, and needed a material that was well insulating, but was also vapor permeable. So France has had a long history of hemp growing and a hemp industry, and they looked at using the hemp fibre because it's got a hollow core in it, so it's very good at insulating, and it's also very strong. But the hemp buildings that started in France are not the only ones. There's a building in Miyasa in Japan, which is a traditional hemp growing area, which is over 300 years old. So it does have some longevity there. Why didn't we build in Australia with it earlier? Well, part of the reason is that it wasn't legal to grow hemp. New South Wales was one of the first states in Australia, and in 2008 it became legal to grow industrial hemp. You might wonder what the difference between industrial hemp and marijuana are, is that industrial hemp has a low THC content, and that actually needs to be measured. So there are no psychoactive properties in the industrial hemp. So why would you build with hemp? Well, from a bushfire point of view, first of all, it's non-combustible. So I'll go through and show some fire testing just to prove how non-combustible it is. But apart from that, hempcrete has some wonderful properties. It has good insulation. It also has a bit of thermal mass, which means you get very stable indoor temperatures. The walls are also vapor permeable, which means that you never get a buildup of humidity inside, and the humidity regulation properties of the walls also help to balance out the temperature. With the hempcrete also, it's very good at, just by the nature of the material and how it's installed, at eliminating thermal bridges, because the frame is actually in the centre of the hemp wall. So that protects the frame from both fire contact and eliminates thermal bridges. The solid wall is also beneficial from a bushfire point of view, because with no cavity, there's nowhere for embers to get in. And in fact, most buildings in a bushfire area will burn down from ember attack rather than direct flame contact. So the hemp product also, hemp is a very fast growing crop, growing in 3 to 4 months. So if you compare that to even the fastest growing timbers taking 20 to 25 years. So what that means is that the carbon which is in that material can be locked up in that material, and then once it's in your wall, it stays there. So even taking into account the energy and CO2 in the lime-based binder, it's actually a zero carbon building material, also very low in embodied energy. So a couple other great things, yep, quite compatible with conventional building practices, and a lot more so than many of the other natural building products. So in terms of that, we're looking at how do you build with hemp. So this is the house at Blackheath under construction, and you can see it has a standard timber frame, which has been done in accordance with the standard timber framing code. So really easy. It can either be built, the frame can either be built on site or off-site in a framing factory. The hemp is then sort of mixed in a flat sort of pan mixer with water and a lime-based binder, placed into the formwork. It is tamped down. It is not rammed down, because you don't want to push all the air out You just want to have the particles interlocked with each other so that they hold in place. The other great thing from a construction point of view is that all the services are put in the walls first prior to the pouring of the hemp, which makes it quite easy, although you need to make sure that you have a good electrical and plumbing plan so you know where everything's going to go. So at the property at Blackheath, the owners actually cast the walls themselves. So here they are sort of working on the site. The big green thing is the mixer where it was all mixed up in. They also did some fantastic details. They wanted the thick walls, which in this case they're 300 thick, and that was largely for better insulation because Blackheath is quite a cold area. But they did this wonderful sort of curved formwork around the windows using quarter plumbing pipe, which when you can see that when it was rendered gives a really lovely finish there. So on the Blackheath house, the hempcrete was installed what they call cast in situ, but hempcrete can also be used as hemp blocks. So they're preformed and are effectively glued together. You still need a structural frame for that, whether that frame is timber, steel or concrete. Also, hempcrete can be spray installed for faster installation. Popular in Europe is also hemp insulation bats. We're not manufacturing those here in Australia, but there are a number of companies working on that. So hopefully we will have that product available in the future. So in terms of the hempcrete wall construction, as I described earlier, the frame is located in the middle of the wall, which is great, protecting your frame from both fire and termites. And then on the outside, there is usually a render finish. Those renders need to be vapor permeable because the wall is vapor permeable. On the inside, you can either leave it unrendered and finish it with a vapor permeable finish, or you can also render it on the inside with either clay or lime. So in terms of that, there are a number of products on the Australian market. I've just picked out two of the more popular ones and sort of looked at, well, what have they done in terms of their fire testing? So the first one is the Tradical hempcrete, which is distributed in Australia by Ozhemp. And a 300mm thick wall will get you a 60-minute fire rating, which is more than enough for BAL-FZ. So BAL-FZ only requires a 30-minute fire rating, and they have that code mark certified, so that can be used for the BAL-FZ. The Australian Hemp Masonry Company, that is a binder that's manufactured in Australia. They've only had theirs tested to BAL-40 so far, but I have no doubt that when they do test it for BAL-FZ that it will comply, because certainly the hempcrete can withstand significant temperatures without either igniting or spreading any fire. So there's been on the internet quite a lot of these sort of blowtorch tests, and just to sort of show that they're not sort of faked, I actually did my own half-hour blowtorch test on a 100mm block of hempcrete. This has actually been taken from an academic paper, the photos I've got here. But it actually goes and shows you what the temperature is of that hempcrete block, subject to the blowtorch. So during my own half-hour fire test on a hempcrete block, and it was an unrendered hempcrete block, because if you render it, it actually gives it even more fire protection, but had absolutely no flaming. Certainly did have some charring of the outside, but even at the end of that test, I could put my hand behind that 100mm hempcrete block and only feel a little tiny bit of warmth. And that's one of the real benefits of hempcrete. Not only is it non-combustible, but it provides you really good insulation if you are in a bushfire situation, because you need to be protected not just from fire ignition, but also from that radiant heat. I see if this this video will work. Just, oh, here we go. It's only quick. The relevant thing I was wanting to sort of show in relation to this video, this is actually a rendered panel. But here they go. This is using a thermal camera. Although the person who did this test actually showed me that the camera only went up to 120 degrees. So at the front, it was probably a lot hotter than 120 degrees. But as you can see, it's showing about 8 degrees at the back of that block, even though it was significantly hotter at the front. So that's the benefits of protecting from radiant heat as well as from flame ignition. Sorry, and this is actually, they also did a full 2-story fire test in France. So this is actually, I'll just sort of, a much larger scale test. In this particular one, they had timber windows and they also had a timber first floor. The timber windows burnt out, but no problems with any issue with the wall. You can see actually how large the timber cribs they were put in there, which is certainly larger than the ones they use for BALFZ testing in Australia. But even after 2 hours, yeah, there was no ignition. So that goes to show just how fireproof the hempcrete can be. This is also a house in Nelligan, which actually went through the December 2019 fires. You can see how the area around it is completely burnt. Sadly, the neighbour's house, which was brick veneer, was actually burnt down. This house never actually got direct flame contact because the owners were on site and were defending the house. But I spoke with the owner and she said that, look, she was always reassured that if it became too dangerous for her to remain fighting that fire, that she would have retreated to the house, knowing that that would be non-combustible. And despite the fact that they actually got direct fire, they were actually, the house was only built to BAL 29. So there's some real benefits that if you can, building higher than the BAL, minimum BAL rating that you are given for the house. This is a hemp block factory in Western Australia, which in fact got burned. And this is in February 2022. And the lower picture, you can see there's some blocks in the foreground and there are some blocks in the background. Both of those sets of blocks went through the fire. And in fact, they weren't just burnt once, they were burnt twice because the fire changed direction and burnt back over the property again. The blocks in the background were cured blocks, which had dried. And you can see there's absolutely no damage. The pallet they were sitting on was timber and it completely burnt out. The blocks in the foreground were recently made prior to the fire and had not dried yet. So they did show some damage, which would have been caused by, there was sort of moisture during those blocks. But the fully cured blocks had no problems at all going through bushfire twice. So generally, the hempcrete walls are finished with a lime render, which provides even more fire protection. Here are some pictures of the house at Blackheath with the first coat of render and then with the second coat of render, and those absolutely beautiful window reveals and lovely sort of soft lime render finish. In terms of then what a hempcrete house can look like, it can look like anything. So the hempcrete will take the form of the formwork. So you can go from traditional to contemporary, you can clad it, not really suitable in a high bushfire area, but certainly a possibility. In terms of that, just looking at the thermal bridges in the hempcrete wall, you can see that this is my first hempcrete house that I built for myself. I learned a few lessons there. In those corners, you can see absolutely no thermal bridging through there. my double glazed windows, clearly I'm losing quite a lot of heat through those aluminium frames. Lesson learnt there. Didn't have slab edge insulation, and I can absolutely see the heat coming out through the slab. But in terms of the walls themselves, really fantastic, showing sort of even temperature, no thermal bridges, good insulation there. In terms of approval for something like hempcrete, in order to get approval, it's basically a performance solution. So the Tradical binder that I referred to earlier, it has code mark certification. Otherwise, you need to have a performance solution. So most of the companies that actually sell the binders will provide you with the necessary documentation for you to obtain a council approval for use of their product. So that's the AusHemp's code mark certificate. And yes, if you're interested in further reading about hempcrete, there's some fantastic resources for you. So I will flick out. Oh, also, in Australia, if you're looking at building out of hempcrete, there's a fantastic online resource called the Hemp Building Directory at hempbuilding.au, and it lists architects and building designers, builders, certifiers, engineers, suppliers, so that people who are looking to build out of hempcrete can know who they can sort of work with on those projects. And if you're a building designer who's working with hempcrete, please click on there and you can get your free listing. So that is my discussion about using hempcrete. Just a moment. I'll stop sharing. As a solution to dealing with building in high bushfire areas. I'm now going to go through and ask the questions. So I've got a few questions. Question from Vaughan: if a bushfire, have we answered that one? If the bushfire was to hit a home, how much of the facade is expected to require replacement? I can indicate that in terms of the hempcrete house, you may need to patch the render a little bit if it's charred, but otherwise that's going to be fine. I suspect there might be more of an issue with potential damage to your ColourBond roof. How about you, Corey? How much would you expect to have to replace if a fire hit the house?
Yeah, I think a fair bit of it. You probably have to replace the cladding on the walls if it is just a metal cladding, and the standard only calls for a minimum 30 minutes. So that the idea is that it protects the occupants during the fire front passing. So it's not actually the Australian standard isn't to keep the whole building intact because that's cost prohibitive, I think. But obviously there's systems and ways that you can, like the hempcrete, more masonry products will obviously stand up a lot better than claddings and those sort of things, and hemp. Yeah, so the other options there. And
also, Corey, so how did you protect those highlight windows?
They were flame zone rated glass. So the most expensive one, because this was a question others asked, was the triangular one above the kitchen was $6,000 for that particular window. So pretty
fantastic. Yeah. Well, it's obviously a choice that the clients wanted to make to get that architectural design.
Yeah.
Question also in relation to the frame, which I presume is in the hempcrete wall, about whether that needs to be treated pine. Absolutely not. Generally, most of the pine that goes into timber frames these days is actually H2 treated for termites. But provided you do your standard termite detailing, which we all need to do on all of our buildings, of course, regardless of whether the frame is treated or not, then you do not need to have a treated frame inside the hempcrete wall. Another question in relation to hemp: will it resist heavy rain? In terms of that, it's a good idea to have good eaves on your hempcrete house. If you don't, then it's wise to put a vapor permeable finish on the outside of your render to try and repel that additional water. So with good eaves, if the walls are subjected to driving rain, then basically they will just dry out. They certainly did some accelerated erosion and weathering testing in Scotland on the hempcrete, and they simulated sort of 200 hours of rain and found that it, I can't remember how long, but it didn't really penetrate very far into the hempcrete walls, and it allowed them to basically just dry out again. So I hope that covers that one. Interesting question in relation to insurance availability with hempcrete walls. I'm particularly knowledgeable about that since I own a hempcrete house. To begin with, I actually had no problems. I was insured with NRMA. I then had to change insurers when I started renting it out. And a few were a little bit funny about it because it was not one of their standard listing items. And because I was renting the house out through Airbnb, I had a limited number of insurers, but had an insurer who would basically insure it on a replacement value. And I had no problems at all. So in terms of that, if you're an owner-occupier, you're likely to have a lot more options in terms of your insurance. So the answer to that question really is occasionally some insurers are a little bit funny about it, but most of them are okay. In terms of that, also a comment about perhaps for you, Corey, what about using steel instead of timber frame?
Yeah, so that's it's possible. There is a national standard for doing that, and there's a job getting done down in Conjola, and really good resources in the Resilient Building Council. They've got a Fortis fully designed steel framed house for our flame zone. Really recommend all building designers have a look at it. It's got a lot of interesting strategies in how to use the steel in it. Obviously with steel though, there is a lot of issues with the thermal performance in terms of thermal bridging through the walls and the steel frame. So that would just need to be very carefully addressed with the positioning of the insulation and possibly woolfy analysis just to make sure there's no condensation issues with it. But yeah, it's definitely a compliant option, not one that I'd probably use because it's so many issues for condensation and reduced performance for the insulation.
Yeah, I think that certainly if you're looking at using steel framing, thermal bridging is a real issue you've got to sort of look at, as well as that issue of condensation, Corey. So if you are looking at steel framing, I think you really do have to consider all of the impacts of using that, as well as simply just the non-combustibility of the steel. Another question come through in relation to the Blackheath Flame Zone house. Yes, they are timber windows, and we did not need to use shutters, and that's because they are from a company called Parhammer, who are the only company in Australia who do a Bal FZ timber window. They use a specific timber called Manning Caldra, and the windows have actually been tested to Bal FZ. So on that particular house, the clients chose to use those windows, which are quite expensive, about $3,000 a square metre. But they wanted to make sure that their house was going to be protected, whether they were at home to close the shutters or not, because that's another issue in relation to shutters. And I think someone's also mentioned, Corey, in relation to your project, were the shutters on like an automatic close, or do the clients have to be home to close those shutters?
Yeah, so there is an option to connect it with a remote close, but that's dependent on you having internet reception at your house, which when a fire goes through, often the telephone line is one of the first things to go down. So it's good, it's convenient for keeping your house closed or opening it up if you're coming home from work, but in the actual fire event, possibly not that great. And most bushfire shutters have a fail-safe in them so that they will close in a fire event. There's also some that are cheaper that I wouldn't normally use because they're just a single use. They can only come down once and can't actually be used for solar control going up and down at other times as well. So I hope that answers that question.
Yeah, so another question for you, Corey, was in relation to the timber in the landscaping. Was that a specific kind of wood that was used for that fencing around the pool and the landscaping, or?
I think it was ironbark around there. But because it was more than 6 meters away from the house, the code calls up that sort of 6 meters closest to the house as being all non-combustible. But after that, so if you're building a garage or a shed within 6 meters or any outbuilding, it needs to be built to the same standard. So the front actually had a carport that was a meter set off the building, but it all had to be built to flame zone standard and construction as well. So that 6 meter sort of separation is important. And one other very important element in terms of passing fire across is actually I learn about a lot in the Resilient Building Council. They've got a new app out for assessing. So if you've got a client that comes to you in the flame zone or bushfire area, they go through that assessment with them, and that a lot of your risk can actually come from the neighbouring properties and where they park their vehicles. So actually proximity to combustible elements is really important in terms of the whole siting of the project as well.
Yeah, I think that's really relevant. And I think that in terms of the pictures I showed of that hempcrete house at Nelligan, which survived the fires, it was also down to the fact that they had a good cleared defendable space around the building, which meant that they didn't have vegetation really close up to that building. Back on the issue of steel frames, Gilberto has asked about whether a steel frame inside the hempcrete walls is a good idea or not. A couple of things. If it's purely from a bushfire point of view, it's not necessary, because the hempcrete around the outside of that timber frame is protecting the timber frame from both radiant heat and direct flame contact. In terms of using steel, because the hempcrete is a vapor permeable material, there is possibly an issue with the steel attracting more condensation, and you certainly want to do a roofie analysis on that. But also from the point of view of embodied energy, steel has a lot more embodied energy than timber does. So if we're looking at reducing the overall embodied energy of our buildings, then I don't think that sort of steel is the way to go there. Another question in relation to, I suppose, comment, and again, that comes back to embodied energy and reusability and recyclability, is in relation to using PIR foam panels. I'm not aware that any of them have actually been rated for BAL FZ. I know they've got them up to BAL 40. But in terms of that, if you are looking at those PIR type foam panels, I would definitely look at issues in terms of they are definitely not vapor permeable. So you're going to have a look at the issue of how you're going to manage condensation in the building, or just vapor drive, and also in terms of embodied energy and recyclability. I think that we all need to be looking at those issues when we're choosing building materials. Question also, who was the aluminium cladding manufacturer? That's obviously for you, Corey.
Yes, it's Vitrolock. Fairview is the company that make that. I've just put the link in the Q&A, so if anyone wants to have a look there, check it out there.
Fantastic. Question, is a damp-proof course needed? I'm assuming that's in relation to the hempcrete walls, and the answer is yes, of course. This is just that's a sensible building practice to prevent any damp coming up, particularly if you're a concrete slab on ground. Yeah, so a lot of sort of standard building practice applies even to non-standard materials. Okay, I think that might be all of our questions. We also have just a couple of questions for you, Corey. Cost.
Oh, yeah. So the pool and landscaping, which was quite extensive, was about 300 grand, and then the house was 1.4 million. So total about 1.7. So it was about 220 square meters. So roughly in the order of around 6 grand a square meter for that build.
Yeah, so the 90 square metre hempcrete house at Blackheath, which is clearly just a slightly different ballpark, it was 450,000. So it works out about 5,000 a square metre. So not particularly cheap. I think that in that particular house, the windows were a significant cost there. They also had very good sort of level of insulation in the floor. So it was quite high spec for the small house. One way of keeping your cost down is keeping the house small, but smaller houses tend to have slightly higher cost per square metre, even though the overall cost can be lower. And that's really just because you need to have all the same sort of services and connections. You don't have quite the same economy of scale. Last couple of questions. We have a couple of comments in the chat. Termite resistance of the hempcrete wall. Yes, they are termite resistant. The hempcrete itself, so termites don't like to chew that, nor do vermin. I can tell you because I retrofitted my son's cubby house with hempcrete because the rats got into the wall, and certainly they didn't touch that hempcrete very happily. But my son grew out of the cubby house. Anyway. But certainly, even if the walls are termite resistant, you still need to do all your building code termite protection. So, well, I hope that, Corey, our discussion has encouraged people, if they do get some high bushfire or flame zone projects, to be able to sort of just look at things in terms of your material choices and your design with a bit of thought, and approach how you can best use materials and design to create a low fire house. Also, just to give a plug to the Renew people, they did a fantastic series on bushfire resilient houses, and I believe that their seminar series is going to be up online soon. So unfortunately that series is finished now, but they will post that, and what I'll do is later on I'll post that in the building designers chat. So thank you very much to everyone for joining us today, and please have a safe holiday season, and we look forward to seeing you all in March next year. Thank you very much.